Well, I think there's a lot of engineering problem we're trying to make it come true. The first thing is the about the localization. This is one of the most largest problem we face, that the robot can't doesn't know where it is. So we are using VEX GPS. Well, before we are trying to use A star to for the path planning. However, the A star takes a lot of times and it can't changing the approach at the end. So we are using the D star to allow it to it's like it could change the just skip it. Okay. Okay. So before we are using A star for the path planning. However, it will not be able to change during the moving. So we are changing it to the D star light. So which allows the robot could be interrupted and changing the ending point real time. Well, I think it should be the core decision system. So the robot acts like a beast. So it just goes anywhere randomly because we don't finish our localization stage. And what's next is we test it again and again, and it's work more stable. So we'll output our entire decision into our UI, and we could know what is the decision do and what it's gonna do in the what it's gonna act in the field. So it will help us to debug easier. And
Right. So, in this case, it would probably be the intake because originally, for example, we didn't expect to be scoring as much as we were supposed to. And because the code is very complex, it thought that scoring multiple times by scoring one or two balls each was the most efficient or the most optimal way. The intake had to be modified to be made smaller so that it could fit a secondary intake on the left hand and right hand side. A time that we had to like repair and then get it right back to working was at the Worlds competition. So during our match, we found out that our D score arm, or in this case our wing, wasn't lifting as high as it was supposed to. And so we fixed this by just tightening the string so that when the intake lifts up, our wing also lifts up. And so right after this, we just went back to the competition to continue our practice and also our matches.
so we pre-coded like with a lot of different kind of situations. And one example is when the robot getting blocked by the another robot. So it needs to cancel its motion immediately to prevent the DQ and the descoring by ourselves. So this is our another innovation that we use UDP radio to allow two robots communication together. So our robot one is act as a master robot, and robot two is the smaller one is a slave. So the bigger robot will send a command to the smaller one and allows it to do the actions at the same time. So because the VEX GPS have some problems on its reflection time, so we're trying to use LiDAR to localize. However, it's like 10 days before match, and we didn't finish the LiDAR, so the localization still, we are still using the GPS, which is a little bit slower than what we expect.
Right. So the reason to why our notebook ended up being 1,200 pages was because our code is very complex. Our code includes different strategies, how the robot thinks, and also a lot of the training. And so we want to have have a very detailed documentation of this to make sure that the people reading our notebook can understand how the code work and what's going on inside the minds of our robot.
So we do document our successes, but the reason why we document things other than successes is to mainly record our robot's progress, each system, mechanic, or game strategy we tested, and that both improves our next season skills and uh, our ability to remember the small things.
We believe something that's very nice about our documentation is the fact that our AI system is fully autonomous. All this, for example, all the decisions that it makes are based on what's happening at the match. It'll make its own strategies, it'll abandon its own tasks depending on what the state of the field is.